here we have the coordinate plane, and this is our 1 unit of x-axis and this is 1 unit of y-axis. Okay, and this end point of 1 unit is represented by 1, 0 as per this coordinate plane, and this 1 unit is given by this. Okay, so now we are going to transform this entire plane, and to transform this we basically have to transform these basis units. So this x-axis means this 1 unit is going to be shifted to 1 comma minus 2, that means this point here. So our 1 unit of the new plane is going to be this, means 1 unit of the x-axis of the new plane. Okay, and 1 unit of the y-axis of the new plane is actually going to be this. So we have to make the new coordinate system with this transformation. Okay, so let's make the coordinate axis first. So these are the two coordinate axes, where green one is the x-axis and the blue one is going to be serve as the y-axis. And our new coordinate plane as per these units is actually this one. This grid of blue and green is the new coordinate plane. You had this table to fill in. In the previously linked video, you were clearly explained that to determine the position of any point after transformation, it is enough to know the transformation of its two-dimensional basis units. Because even after transformation, every point is actually the same combination of its basis units as it was before transformation. What does this mean? Let's see. Let's take a point 3,7 in the old coordinate system. As per coordinate geometry, this point is at a horizontal distance of 3 units and a vertical distance of 7 units from the origin. And in vector algebra, we may say that the position of this vector is actually 3i hat plus 7j hat. That means 3 times this vector plus 7 times this vector. So when the whole coordinate plane will change, means after the transformation this point will also change. See, the I hat is changing to this position and the j hat is changing to this position, so this will also change its position. So what's the concept? That the position of this point is going to be of the same combination as it was having with the old coordinate old basis vectors. Okay, so what was the old combination? It was 3 times I hat and 3 times j hat. So in the new position also, this point will shift to 3 new I hat plus 7 new j hat. So let's find out the position of this point visually. Let's develop our new coordinate system. This is the new grid here. So let's see where will this point will shift. So 3 I hat and 7 j hat. So this is our origin. 3 I hat, the green is the x-axis, so positive 3, so 1 2 3. Okay, and 7 j hat, so positive, that's why 1 2 3 4 5 6 7. So this point here. Okay, and so what's the point here? This is 17 comma 1. So this point is going to shift to this point after transformation. And what is the position of this point? The position of this point is 3 comma 7 with respect to the new grid. Okay, and 17 comma 1 with respect to the old coordinate system, means the old grid. Now in this table, these entries can be easily filled in. Position with respect to old grid is this. So position with respect to new grid is going to be this only. And here also. So these are the entries now. Now after transformation, position of 3 comma 7 with respect to old grid. So we have seen it visually and we know its answer. The answer is this. Okay, and of course we know the answer for this also, no, because the position of 1 comma 0 of new grid, we started the video with this only. So these we know by chance, but we have to have a mathematical way to sort all of them up. Okay, so what's the mathematical way do we have? Let's see.
Now this is a point in the old grid. After linear transformation, its position with respect to old grid will change. With respect to new grid, it will remain 3 comma 7. But with respect to old, it will change because the position is actually changing. And what to do to know that new position? We just need to know how does the position of I hat and j hat has changed. That's enough to tell the position of any changed point. So the I hat was actually on, means in the old grid it was on this, and it has changed to I suppose 1 comma minus 2. No, yeah, this one only. And your j hat was initially at this position, sorry, 0 comma 1, and it has changed to 2 comma 1. So this is how I hat has changed. No, so these are the new positions of I hat and j hat with respect to the old coordinate system only. No, so how will this change? As we discussed earlier, so this point will be affected by the x coordinate of I hat and j hat, and this point will be affected by the y coordinate of I hat and j hat. So how do we have to write it? So this is x coordinate of I hat, new I hat, and y coordinate of uh, new I hat. Okay, and similarly this one are the x and y coordinate of new j hat. Okay, so now the point 3 comma 7, this will be affected by this transition. 3 will be affected by the x coordinate of both, and 7 will be affected by the y coordinate of both. This is the example for, means a known example for this tricky matrix multiplication. Okay, and the whole idea of proposing these videos was this only. Okay, so if we write them in this manner, and if we multiply them like 1 into 3 and 2 into 7, then we can actually understand what is going on. No, so conventionally that's why the multiplication is kept. So the new, to find out the new position, we'll do the matrix multiplication, conventional multiplication, so which is 1 into 3 plus 2 into 7, and here we have minus 2 into 3 plus 1 into 7, which is basically is equals to 3 plus 14, and here we have minus 6 plus 7. Okay, so here you can see that this is 17 and sorry plus 1, 17 and plus 1. So the transformed position for this is actually 17 comma 1. Okay, so this is with respect to old, and this is also with respect to old grid. Okay, and but this is before transformation and this is after transformation.
So we learned how to mathematically find out the position of any point with respect to old grid after the transformation. We worked on this example, and on the similar lines we can work on the rest. Please try them out and try to meet these answers. Thank you.